Jo. Untitled. That's some kind of like backup solution for one colleague here that doesn't run Linux. I got few available to just connect to my machine and try out the same stuff. The question is like really if the network here will allow some connection. We will need a system with a libvirt inside which we'll be running another CentOS systems, which will be fun. And I believe there's a system that doesn't like that kind of nest thingy, so let's see if at least some alternative will go. Okay, so for another people coming in who would like to join me in doing something, here are some flash drives to copy some files. So who wants some? Who wants some data to copy? Or who got finished copying and needs another flash drive? Okay, you just finished. Okay. Someone else? 2 flash drives available. 3. Containing some materials we'll be working with. Some prerequisites. We will need some Linux system, unfortunately.
Okay, I have some.
And one colleague here is testing if we can use some workarounds for those that doesn't have or for some other reason. Okay, so alternative approach doesn't look to work, which we can at least blame the network. Okay then.
I can download VirtualBox image on how we're doing it. I can manage it on the stopper.
Yeah, there's some limitation for that approach, but you can try it out and we will take some alternative. So, okay, let's stop maybe with the side chatting and let's get a proper start, as I was walking around here and doing quite a lot of chit-chatting and so on. So, good morning everyone. Thank you for waking up so early. Some of you seeing on the party, some of you not, but coming for the morning workshop about creating high availability clusters with Ansible. So, who knows Ansible? Hands up. Great. Who ever configured some high availability cluster? Hands up. Good, still good. So, okay. We will be doing a practical part a lot, meaning I would like to show you how to create such a high availability cluster here. We got some flash drives running around here. If someone needs some more, I still got one here lonely. We will need some Linux system, also file system. We will need some paper that you have on your desks. It got 2 sides, just note them. They contain some instructions, and the other side of the paper contains what we actually will be doing in a cryptic language called a natural language, I would call it. Sentences with subjects, objects, whatever else. A little bit made into the form so it's easier to write something in Ansible. So, and most important part, my name is Ondrej Famera, so just you know my name. And a little bit of introduction, I work in Red Hat as a support engineer in a clustering team, so I believe it's highly relevant for me to present something with the clusters. And I will show you why I use this approach for doing some stuff, as I find it really fast and useful. So, a little bit of summary with a picture what we will actually do today. We will do a 2-node pacemaker cluster, 2-node highly available pacemaker cluster with some clustered resource. In our approach and the picture that is taken from the documentation, we'll be setting up highly available Apache server, running on some IP address, serving some nice web page. that can survive one of the nodes failure and still the user will see the web page. So fairly simple thing, and this will be our objective. One important part before we dive deeper, and also if still someone doesn't have a flash drive and has copied the file, ask for it. What is highly available or high availability cluster? Or what is the difference between high availability cluster and zero downtime cluster? Can anyone tell? Who thinks that will be able to tell? Hands up. One person only. Okay. So, in short, high availability cluster is trying to achieve nearly 100% availability of resources. And the important part is trying to achieve, not achieving. So we must consider that when we are running something highly available, it doesn't mean it runs all the time. It means it runs most of the time. And the objective of the clustering software is to make it run as much as possible, ideally close to 100%, which is not achievable in most of the scenarios, but could be. Imagine nothing goes wrong for a year, for example, which is very rare. So there is expected that there will be some downtime. But the objective of the cluster is to minimize this downtime and enable either the administrators or the operators of the clusters to not need to take care of it, let the software take care of problems and solving them. So we will try to do some actual work as was introduced in the beginning. We will be needing a Linux system with a libvirt, pair of virtual machines, and some additional storage. And I will be going with you, showing off all the stuff, how we create it and how we go forward through it and start working on the cluster part. In the meantime, there will be some breaks for introducing some concepts of clusters, which might be relevant to the parts that we'll be doing. I will be using mostly the breaks while something will be running or something will be stuck, as it might happen that some stuff will just take some time. Most of the stuff that is prepared here should be able to run without internet connection. So if you get the files on your computer, it should work. However, I might not promise that something changed overnight or whatever, and something might just require downloading a little bit of data. But most of the stuff should be workable for production without internet connection. So, to what we need, and some nice table with the stuff, we'll need 2 virtual machines. So for those that already got copied the files, you got the directory named VM, in which you have 2 files. One of them is file for defining the virtual machine in a libvirt. It's the small one. The second one is the disk drive with some pre-installed system. Some pre-installed system, it's CentOS 7.3 with few packages already installed. For those curious which packages they are mostly those ones that we'll be using today, and information on exactly steps taken to that will be disclosed somewhere on my webpage. So fairly minimal one. Yes?
Question. I have Ubuntu. I see there. I don't need CentOS as a host, right?
Nope.
Okay. I just need QEMU to extract him.
Yep. As a host, we need something that get a libvirt, and one additional thing that get a fancvirt-d. Despite this might not be needed that much, it's the proper way how to do one part of the clustering that I will be talking a bit later on. So it might be just not named the same way in the host. This kind of fancvirt-d or fancvirt-d, libvirt, and the other stuff. Obviously, we will need Ansible, pretty recent one, or at least something around the version 2.0. 1.9 should also do the trick in most of the cases, but I haven't tested it on that kind of it, but still might work. And you will need a paper that is around here. So let's get stuff rolling. I will be trying to do the same stuff as shown here with you, so we will see what is happening. If someone comes just to watch, yeah, you will see me doing the same stuff as all the others will be doing here. So don't worry if you don't do it yourself, you will have at least interactive look at how the stuff works, or if I make something wrong, how it breaks. So in any situation, if you got questions, feel free to ask or interrupt me. I'm expecting this to be quite interactive in a way that we'll be setting up something gets broken, and we might just fix something. So, yeah?
You know, on this flash disk, the files were corrupted, so I don't know.
Yeah, on my also media is corrupted. I don't know if the image is also corrupted.
Okay, there is another
This,
paper.
okay. This is okay.
Yep.
That's okay.
So which one is
So
the
right,
right
this
one?
is okay. This is corrupted.
Okay. Good. If you get image, the big file, there is also the checksum next to it. So if you get a suspicion something is really wrong there, this is the good one. Okay. So if you got suspicion for corruption, bring the flash drive here. I got already 2 corrupted so far. So we are quite good. And I should have one more here. So let's get down to the terminal. And I will have a tough decision for you to make. Is this white screen looking nice to you? And my question is like, oh yeah, the different, the normal black text, can everyone see? Or at least too small? Okay. So let's give you opportunity to change, and let's try it like this. Okay. Yeah, I know, it's like choosing between
Oh, okay.
And then like blue, so it's good.
yeah, but don't mind the blue one, because the blue one will be not that much there. Just my question is like, let's try it with a vote. Who likes the white one? Hands up. Okay, 5. Who likes the black one? More people. So who is sleeping? Great. Okay, so looks like the black one got slightly more votes. So sorry guys for the white one. Personally, I like the black one more. So it's more relaxing and you can sleep with it and so on. So let's get somewhere to creating some machines. So as I promised, I will be trying to do the same stuff as it's mentioned somewhere. So let's get the virtual machines up and spinning. We will need 2 virtual machines. You got 1 file. That means one important thing. You will have to have a copy of that file. Who didn't figure out that yet? So I got the data hidden here. So let's get the virtual machine image. So I will copy the disk image somewhere, and I will most probably need a root. So for those that already got libvirt, the most natural place where to put some images is varlib libvirt images, which is storage which even on the Linux enabled system should be safe one to put files into. So let's get the data there. I will therefore take the VM disk image, make a copy of it, unpack it. It should really take some time. Believe me, this is the fast unpacking one. I tried several ones of them. The best compression ratio was pretty impressive, but it took like 5 minutes to unpack. This is 40 seconds on the same machine. So once the file gets unpacked, it's around 1.5 gigs. We will need 2 of them. This will be the base virtual machines that we'll use as a cluster nodes on which we will do some stuff. Yep.
Do you have this image also somewhere online? I set up.
Somewhere online, not yet, but still I can give you a drive for now if you wanna just get it there. It will.
I've set up online demo, but I can't upload the whole image. It's too big.
Ah, okay.
Never mind.
I believe this will be recorded, and if not, then.
I think it's going to be recorded.
But the image there. However, baking here is done, so I will do the trick. I will rename it to node 1, qcov2, for example. Then I will make a sophisticated clone of the virtual machine by using the cp command. Done. And there will be one additional thing that is mentioned here on the slide. I would like to have some shared drive between those 2 virtual machines, which is the tricky part. So we can create this kind of shared drive with nice command. For those that get copied the file, the same presentation is available as a PDF named DevConf something 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 PDF. So you can copy paste it from there. So let's create the shared disk. We should have now 3 disks. And now we need to define some virtual machines. Again, as you might notice, we will need to do some kind of editing there. So let's take the VM definition XML and copy it into node 1 XML, for example. So node 1 XML. The one thing that we will need to change, and you also most probably, as you have named the files, you will need to give the right path to them. So for those really not liking XML, you can try use something else for this, but in general it's really just finding the line with a source file saying node X and change it to whatever you have named the disk file and check if your path is looking the same. So I have named it here node 1. I will call my virtual machine node 1, or let's call it node 01. Who knows what else I got in my system. And the shared disk drive, it's called just the shared disk. So yeah, I've made some change from the original here, so let's put here the shared disk. The easy way to figure out if I done everything okay is to try define the virtual machine in the libvirt, which is as simple as virsh define, and I hope you have a virsh command. So virsh define node 1 XML. So far looks good. So let's make the clone of the machine the geeky way, cp. Let's change the name slightly, and let's change the file of the disk drive slightly. If someone goes with creating your own machine and some clicky interface, you can do it. You can just assign both drives to those machines. There is one small tiny thingy to do, and that is for the shared drive. You should search for some checkbox or something mentioning the drive should be shareable. This will tell the libvirt that more than one machine will be accessing the file or the disk drive, and it will not shout when you try to start both of the machines at the same time. Otherwise, you get the error like, oh, this disk is used by some other machine. You cannot do that. But we actually want to do that. So I will try to define also the second node, which looks fine to be defined. So let's have a look if I got them. I've got them turned off. So let's try to start them up. Is here someone who's scared of the command line? Hands up. Sophia, please. Okay. So the virtual machine that is there can also show something on the graphical output, but you can use the serial console for it, which is a great thingy. So I will do this nice trick of verse start and verse console to demonstrate. So you can actually see something up, and surprisingly it says CentOS, the latest bleeding edge 7.31, updated yesterday evening and this morning again, because some packages. And that one should end up booting up into system, where I allegedly didn't told you the password, so no one can play around while I get there. So we will need 2 machines, both of them booted up, and I will have now a small checkpoint. Who got at least 1 machine running? Hands up. Okay. Who is in process of getting at least 1 machine running? Hands up. Great. So people actually will be doing something here. Great. I'm happy about that. I like the workshops that put work on participants actually. So that's a good thing. So in the meantime, while we get to some working configuration, or at least 2 working virtual machines, which you can do in the meantime, I will have a little bit of talking about the clusters, pacemaker, high availability, and so on. If you think I will be talking for too long and feel too bored, raise your hand and I will ask if you got already the machines up. But promise it wouldn't be too much of talking. So,
Excuse me, what's the password to the VMs?
that's a secret for now. But wait a bit more, just start 2 machines. Once you get 2 machines up, I will tell you the password. And it's not DevConf.
But I know.
You need to add the number at the end. So, for those that want to hear something about the clustering part, what we actually do with clusters and how it actually works. Cluster itself is some gathering or group of several machines that is working together to run some kind of resources. We name them cluster resources. They are managed by the cluster software. And this cluster software is taking care of starting those resources, stopping them, checking if they are still alive or if they are responding well, taking any actions necessary to recover from the issues. And that is quite important stuff, because it means it's usually doing the job that someone else doesn't have to do manually. So the biggest advantage of having a high availability cluster is like you can have a service that runs on one of the machines, and if something happens to a machine, a magic happens and the service will start on some other machine that is working. You don't need to wake up your administrator, you don't need to pick up the phone during the night. It just somehow works most of the time.
Because of pacemaker?
This in general the way how the cluster works. So also thanks to the pacemaker, that's one of the possible representations of cluster software. More detailed, pacemaker is a resource manager, meaning he is taking care of starting, stopping, monitoring the cluster resources, and that is something that we will be creating today, as the CentOS and also the new Fedoras are containing as a primary software the pacemaker resource manager. In the past, who can remember, there was RG manager, resource manager, and even further we can get to the heartbeat, but that's quite something into the past. So we'll be focusing on a pacemaker today and what it can actually do. So as I was mentioning, it is trying to manage the resources, as the resource manager says, and how this is done in some situations that we have a service, it fails, or something happens to the cluster node, then the resource manager needs to decide what should we do. Is there someone making the decisions on where the resource should be run? It should be run only on the machine that we got, for example, connectivity, or it's the machine that is actually working, it's not powered off or something. So for most of the cases that we will need, and also to do some kind of more safety, we will require fencing. So again, a little bit of exercising with the hands. Who knows what is fencing, meaning related to cluster software? I don't mean like killing other people in some nice manner, but who knows it? Hands up. Good. Heard about it. That's also good. I'm working in support, and when I hear from customer never heard about it, I'm getting scared. So why? The answer is data integrity and automated recovery. So fencing, by its idea, it's something that helps in a cluster to determine it's safe to do some procedure. It helps us to say that, okay, we have, for example, our 2-node cluster. We are communicating all the time in a cluster saying like, okay, nothing is happening, everything is working, everything is fine. And suddenly we stop receiving some chit-chat from the other node, and what to do now? Imagine I'm the node 1, here I got Sophia, the node 2. We are usually chatting a lot during the day, and then suddenly she stopped speaking to me. I remember she was running an Apache resource that was serving a web page to some important site. And what to do now? What should I do? I would say like, okay, she's not responding, so maybe it's not working there, I should start it up. But the question is like, we have something in common. We have the web page on one file system. Let's imagine it ext4. What if she's still serving that web page, only I don't know about it? And I will say, okay, we have a shared storage, so why not to just mount the ext4 file system and serve it myself? Why not? Because what if I'm the second one mounting it and you don't want to see the disaster happening afterwards? So the idea is, here comes the fencing, and the fencing tries to prevent us from doing the data corruption, or in nicer words, to keep data integrity. So whenever I'm not sure if Sophia is just not talking to me for some time because she's busy for a while and will be responding to me a bit later, that is acceptable for me, or if she really just passed off, she is sleeping, I need to ensure that whenever she was running something shared with me, that she is not touching it or using it. So for that, I use fencing. Fencing in the form that we will be doing today, called power fencing, is about like, okay, so she is not responding, it's more than I'm willing to take. This more than I'm willing to take, it's called a timeout. And I decided it's over, it cannot go like this, I need to keep the service highly available. So I will fence Sophia, meaning I will power her off and power her on in the best belief that she will recover from some problem. And the point is, once I try to power her off and I got information from so-called the fencing agent, which can be some script, it can be some management device on the server that can tell us, yeah, the server is now down. Until that information, I won't touch any of the resources that she was running. But once I get confirmation that, yeah, she is not there, like she's powered off, that I'm sure that, okay, she should be not holding any resource, so I can mount it and start the cluster resources, meaning I achieve high availability. And this is basically the fencing. There are several approaches how to do it. The power fencing is the nice automatic one, as the cluster, when detects some issue, will do itself usually a reboot of the other node, and once it's confirmed the other node is not running, it can take the resources. The other approaches that we can take if we don't have such a device, or if we have some other restrictions, usually call them like security considerations, that we should not be able to just power off the other machine. We will focus on data integrity, meaning we are still interested in protecting the actual data. So one of the alternative approaches, so-called fabric fencing, it's based on access to the storage. Sometimes it's possible that your shared storage supports SCSI reservations, which is a horrible term, but in general you can imagine it as everyone who's accessing the storage got its key. So I got my key to the storage, Sophia got the key to the storage, and in case I have a doubt that Sophia is responding, instead of rebooting her, because we cannot do that for some reason, I will just tell the storage, take her key out, lock her out from the access to the storage, which will actually mean that she will stop being able to access the data there. She will be also not able to take out my key, so I'm quite safe. And no matter in which state she is, I can say, okay, once I have taken out her key, I can use the resources there because I'm sure that she cannot access them. So again, I'm preventing the data corruption. Still, corruption can happen because we don't know what everything got there, but as a principle, I'm sure that she cannot do the corruption. The only corruption that I can do is that I can do. The little downside of this,
Or what happened before?
yeah, or that happened before. Only downside to this is
Survey interrupting, but anyone having any problems with internet? Because I'm
Yeah, it's super slow.
trying to download any package, I have like 20 bytes per second.
Yeah, it's normal. Sorry.
It's not normal.
Yeah.
It's normal.
so.
Okay, so what do? Because I tried to download VirtBeam in order to do anything.
Welcome to the club. I'll try to limit the number of repositories you are querying about.
I'm afraid for
I can't even do update. Nothing.
Yeah.
Maybe somebody has that package on the hard drive. Sure. VirtBeam, at least.
Yeah. If you need just few packages, I can share you my LT connection, but not for everyone.
Yep.
I was able to install this libvirt0, but it was the last package.
Okay. I'm sorry for the connection here. I cannot make it much faster. I can try to make you a hotspot here for the mobile data. That might be still viable.
I'm connected on a room and it works well, so if I could somehow share it to you, I could, but I don't know how.
Yeah, but
If you're using
But it works
No, no, no.
very well.
unless you
No, I don't.
But you had a role.
depends on the time. Sometimes it works.
I'm
I
having
know
it right
that
now.
one.
Minutes later.
Really good.
She has another network. She's in the room.
Maybe disconnect and connect through the login back.
okay, just to have a little bit summary, people. Who got at least one VM running? Hands up. Current state? We got 5 people. Who got 2? Great. Wait, that's more. How's that possible? Okay. To not make this just a waiting session, I will move on a little bit forward. It's a bit unfortunate that we are not even able to download some of the packages. The images that you have are already preloaded with packages that we will need, because I was expecting it will be not so good. Looking like it's even worse than not so good. So let's try to move on a little bit. And that's the time I will tell you the password, who didn't already guessed it. It's a DevConf 2017. So you can try to log in into your machines and see if you are in. And I will get back now for a while and get a little bit of working, less chatting. So let's get into my machines. And the most important part, once you start the machine, check the IP address of that machine so you know what you want to access. I also don't know the IP addresses of mine. So the login is root, the password is DevConf 2017. Works, surprisingly. And my IP address of a node 1, I believe. And let's make some note of it. It's this one. So let's keep it somewhere aside. One thing that once you get into your machine, give it a name. Give it some nice name. Ideally the one conforming to RFC conventions for DNS names. So letters, numbers, nothing too ludicrous inside there. I will be not very creative. So I will change my node 1 host name to, let's call it myself, Andre. As I got some example here, you would guess how will be the name of the second node. So the node 1 will be Andre. And okay, that's a node 2. No worries. So let's have a look at another one. So surprisingly, I will use the same password. I will check which IP address I got. Oh, nice. Completely other one. I will call it Sophia to have some real feeling here about it. So again, I will change the host name. Set host name Sophia. Nice. And now I believe that's the old part I needed with root privileges here. Let's get into some normal system. So let's try to log in those systems with SSH. On your systems, do the same. Try to SSH into your virtual machines. The important part is like you will accept the SSH key. And the other part, oh wait, I put the wrong one. Another important thing is like you will see if the host name has changed. So here I see the Andre. That's good. It's on that one that it should be. And let's see if this is Sophia. Yep, that's it. So we will go forward and we will try to log in into our machines using the SSH keys. And I believe we got a slide for that. So who worked with SSH keys? Hands up. Great. A lot of exercising for the morning, isn't it? So easy task. Copy your SSH keys to the virtual machines you have. We will use them. So for those that it looks strange, If you don't have a key, you need to create it using SSH keygen. Then you will just continue with enter, enter, enter. It's pretty easy. Not very secure, to be honest, but for our use case, accessing the machine without password, it will do the trick. So I already have such a key, so I will go ahead and just copy it to both machines, meaning to the Andre machine and to Sophia machine. If everything worked well, I can again check that I get in without being prompted for password, and that is the perfect setup that we will need for doing something in Ansible. So, Ansible questions. Who heard about Ansible roles? Hands up.
Doesn't count if it's yesterday.
Okay, some of you I've been teaching already yesterday on the party. Doesn't count. So, in Ansible, I believe that from amount of Ansible lectures and presentations during the DevConf is not much point in getting through again deeply how to work with it. So just a brief getting through. Ansible, it's a configuration management, as we know. To configure some machine with Ansible, we need access through SSH to the machine, ideally with SSH key, so we don't need to input our password too many times. And we need actually two files. One of them is host inventory, or I call it a hosts file for the Ansible, that is containing the list of the machines on which we'll be doing some actions. The second one is the playbook, which is describing which state of a machine we want to achieve. And yes, really the proper wording is which state we want to achieve. We want a machine to look like this. We are giving it a little bit hint how to get there, but we really want it to look like this. And as mentioned earlier, we have Ansible roles, which is nothing much stranger than just nicely structured playbook containing a lot of hopefully related stuff bundled together, and you can imagine it as role of the web server or role of the system that is configured for synchronizing the time. It's actually something like encapsulation in the other programming languages. If you want to just do a lot of stuff in one group and you want to group it nicely, you can have a role. So we can have a role install role web server. That will do install Apache, change permissions here, put some files here and there, and do some other stuff. But instead of doing the copy paste of this whole stuff, we will put it into some role and have it nicely packaged together. We can also do inclusions with the playbooks themselves, which is very similar to what roles are doing, but there are some minor differences, and the roles have bigger flexibility on some stuff that they provide. I wouldn't be going too much deeper into this, but we will see how the time goes. Maybe we'll get also to that one. So, I hope you are able to log in into your systems with SSH keys. And now let's get some Ansible roles to create a cluster. So, if you got your papers, on the other side that starts with creating HA pacemaker cluster, that whole page is dedicated into describing what we want to do today in a human language, and we will try to rewrite that into Ansible. And as you might guess from the content of USB drive, there are some helpers that will help us a lot in achieving some of the goals. And the biggest one is the role for creating pacemaker cluster, obviously. But it doesn't do everything for us. It do the most of the stuff. But still we will need to give it some tiny touch in the end to do what we want to achieve. So let's start. I will start reading out. Who knows how to do the stuff in the Ansible? Feel free to start. Yeah, you can raise your hands. That's nice exercising, but that's too much hand drawing today. You can start in parallel writing your own Ansible playbooks, trying to do it by yourself. It should be enough that you use just the documentation that is provided in the roles that are on the flash drive, or the roles and modules that is in your default Ansible installation. You should not require the internet, and you can still do the stuff. So I will try to achieve that one without looking into the search engine and do it with you. So first task that we'll go through: create HA cluster using the role HA cluster pacemaker with some name and using some fence key. So let's start writing. I will need some Ansible roles, and to be able to use them, the ones from the flash drives, I will copy them here. So in my directory, I get to the flash drive and I got the roles directory. I will copy it here recursively. In roles, I have several roles that doesn't have to make sense so far, but will do in a moment. And I will start writing some playbook. So let's call it.
In what folder did you copy them? In the workshop directly?
The folder that you need, it's on the flash drive, it's called roles.
Yeah, in what folder did you copy it in?
Copy to your current directory in which you will work.
Okay.
So the layout should be, you have some file, and next to that file you have directory named roles. Should be named roles for a particular reason, how the Ansible is looking up some stuff. So don't make it too fancy. Or if you do, at least make a symlink to that. Yeah, we have more people trying out this stuff. And we will be doing some playbooks. So we'll be doing the playbook, where we will be working on some hosts. I believe it's hosts. I will call them nodes. I know that I will be using the user root, which I'm not running as it right now. I'm using as a normal user, so I need to specify a bit more that I will be using a different user. And I want to use the role that is specified in a paper to do some stuff for me. So there is the name of the role, which I can copy paste. But to have some workout in the morning, let's just rewrite it. And I will need to get some information on what to put there next to achieve some subparts saying create a cluster with the name testxx using fence xvm key. Okay, create a cluster using something that looks like it is there, but what next? So let's have a look at what the role that I'm using is actually having as a default for most of the stuff. And let's search if I can find something related to cluster name or something else. I see that we got here a cluster name variable that I can change. That looks promising. Further, if I skip through all kind of stuff, I can see some fence xvm key location, so that will be also useful for me. Yeah, and it didn't get copied here completely. And that looks like pretty it. So let's augment a little bit the role definition I have here, and it will be really just specifying the cluster name. And let's call it, I will call this cluster morning. Yeah, like the cluster name morning. And let's use the fence xvm key that will be located, I hope, in my local directory, but first I need to copy it from the drive. So there is actually fence xvm key. Let's make it available just next to my playbook. And let's specify it there. So, looks fine. This one part of what the Ansible needs, it's telling it into what state we want to get. But another thing that we want to tell Ansible is on which machines this stuff should be done. So we need something like a host file. And again, you have two examples on the USB flash drive, which is at the moment unnecessary because the second one was prepared for the case that someone can connect to my computer. So you can just follow the host normal, which describes some example host file or host file inventory for the Ansible that we might like to use. So in this one, you need to specify two things. One is the IP address of your machine, and the second one is the name of your machine, of your virtual machine, how it is named on the hypervisor. And why that? The answer is again hidden a little bit in the defaults of the pacemaker role that is doing a lot of stuff for us. It will be trying to do some fencing for us. And there is a small note. You need to define the hypervisor host name in inventory for each cluster node. So the role can configure the fencing for you automatically. And by default, it is trying to do so. So in that case, my virtual machines were named nodes, and I believe it was 01 and 02. So name them accordingly to what you have created. And one of the first stuff that you can try out is to run the playbook in the dry run mode. And everything should start looking nice. So let's make a little bit of space on my screen from the unneeded part. And let's have a look on how this will look like. Something is obviously wrong. Okay, who can guess what is wrong here?
Group name.
One more time.
Group name. Host name.
Host name.
The name of nodes. You don't have nodes group.
Yep. Great. Here I have a group named cluster, and I named the stuff I have in my playbook nodes. So let's try it one more time. Yes, it's it. We don't have any prizes this year, I think, here for great answers. So if I run it, no, we actually got the cookies here. So great idea. Please serve the gentleman with a cookie of the prize. So, who is able to get the playbook running at least in the check mode, or who is struggling with it? Yep. I can show you the play.
No, I need command. Sorry.
Ah, sorry then.
Yeah.
Command looks like Ansible-playbook dash, and my spelling English sucks, so dash the little thingy with a dot, space host, specifying the file containing the host inventory, and space the name of the playbook, space dash dash check, meaning actually don't do anything, just tell what will be done. Yep.
Yeah, so maybe you just explained it, what the class code will check do, so it will just run the playbook without doing any changes?
Yes.
Yeah,
It will try to run the playbook without any changes, and if you see the output similar to mine, that it didn't get stuck after a first screen, it usually means everything is good. That's the first.
Yeah, mine fails on some copy fence xvmt. Okay, I have that path for it.
Okay, so check if the file is
Yeah.
in the directory there. And because we'll be going to the fencing part, I forgot to mention one thing, very important one, and that is we need some daemon who will be actually doing the fencing on the hypervisor. And I'm not sure how much of you will be able to download or install it, so we will try to maybe continue without it, but it's essential part for the cluster to work properly. If you ask me if it's really necessary needed, I will always tell you yes, of course, but there are some tricks that we can use to make it satisfied, at least for a presentation. So for those that are able to download some packages, and I will switch a little bit to the slides, what we would like to do is to install the fence-virt-d daemon on your laptop. And here we got something that should work in CentOS, Fedora, RHEL. Yeah, RHEL should be also the one. On some other systems, try to searching for virt-d or fence-virt-d with either underscore or something else. It should be pretty small package, so not a big beast. It's a small daemon that does one thing, and it is that it runs on the hypervisor, so-called your notebook, and it listens for some clients to send him request, reboot this virtual machine, or stop this virtual machine, tell me what machines are there. So it is pretending to be something like a management card for the virtual machines. Our cluster would like to use this for doing the fencing, and to do this fencing it is using the fence key that you are now copying to your machine. And for those ones that were able to get with the playbooks to some reasonable state, feel free to run it now without -- check. It will take a little bit. The point with the fence-virt-d and the fence key is that both the cluster node and the hypervisor got the same key. If they got the same key, they trust each other, obviously, and they can do the rebooting of the other machines if needed. So if someone got it installed and want to use it, feel free, it will be great. I will show you how the configuration looks like. It's pretty easy one. For those that didn't manage it due to internet connection, don't worry. We can still continue without it, but don't consider that to be really good cluster. So,
I used my own images of CentOS, and there was one more. I needed to download. It was a PCS.
PCS on the host.
On nodes, on virtual machines.
Mm-hmm.
But probably it was not the last thing. During the enable of xvm, I got that the module name PCSS was missing.
Okay, I will have a look in a while. Just let me show first the configuration on the hypervisor, and then I will get there. We are getting closer to the things are getting broken part, so be ready for the stuff. So on the hypervisor part, the configuration is usually located in etc/fence_virt.conf. It's pretty easy configuration where you need 3 things or 2 things, depending on how much your default diverts from what we need. Important part that you need is to specify the interface on which the daemon will be listening, and this is the interface where your virtual machines are. So on hypervisor there will be typically vir br0 or something else, and on that interface it will be listening. Then you need to specify a key file that it will be using. This should be the same file as you get on the flash drive, or if you create your own, just specify your own to the cluster that we'll be doing. And in some cases, you would have to configure the backend for delivered with listener multicast. But in most of the cases, this is the default ship with the distributions. But should not be problem. So I have this FenceBird-D. It's a compiled one, so you can see a really strange path here. Don't worry about it. It's running somewhere. I hope. Yes, it's running here for me. So that is something that will be great if you have. If you don't, it might be a bit tricky a bit later on, but don't worry, we can continue without it. So let me have a look at someone who got a problem, and I will let in the meantime this playbook I have created to do some stuff. So for those that want to watch, this is the part. Yes?
I want just some help because the cluster name needs to be some string, some concrete string, because I named the cluster name as cluster, and it doesn't. Maybe that's a problem. I don't know. In the guide there is something that it needs to be named as Dixie. I will show you what is that. Yeah.
Okay. This is something else.
I was looking at the role thing, and this is it.
No, that should be okay.
Okay.
Try to just run it again. We'll see what will be there. And I will go here. And maybe I will see there. Yeah. The part with the fence XVM might be failing if the FenceBird-D is not there, but it's something that we can neglect at some point. So it is expected it will fail during the dash check dry run. That is the expected one because we don't have a running cluster. And apparently it's quite surprising that it gets that far.
Okay, this is with the check, so with the check it might fail at some point. I assume.
So I can run it without check.
Yeah.
Yeah, okay, so this may be expected. So I will just run it through.
Yes.
You say this is correct because of the
Yep.
runs.
Okay, so people, let's try it without check. Let's turn the safeties off. And
Can you show me the
Come on.
confa and playbook?
yep.
Okay. Yeah, without the check it doesn't fail.
Yep, and I was initially planning to give you the solutions on the USB drive, but I decided it would be much better to hide it for a while. But for those ones interested too much in how the whole stuff is done, feel free to stop by after presentation and you will get your copy of the solutions for the stuff that we are doing here. They will be also available online, but if someone cannot live without it, I have them here. So, I will run it just one more time without the check so we can see that nothing needs to be changed in there. And you can also wait for it to get finished and see if the cluster will get created. Once this whole thing finished, you actually create your cluster. So, not that much of a tough job so far. If you want to see how it looks manually done, you can have a look at the paper in the front in the useful resources part. The first horrible long link, links to documentation, creating the cluster. It's the RHEL documentation, but it's relevant for CentOS and also should be relevant for Fedora. Depending if the really the newest one didn't change something, but it should be still relevant there. So, in my case, it looks like we got a cluster, but that was not the whole point of the task that we got there. We wanted to actually create some cluster resource, and I couldn't find a better cluster resource than the one that is shipped with Pacemaker that literally does nothing, and it's a dummy one. And it's named dummy, so let's create a dummy resource. And here we get into a little bit more of clustering and the naming there, so feel free to stop me if you get lost and something, I will try to explain it first, but if you're still not sure, stop me. So,
A question. If you set up this, this is correct or not?
yep, this is correct if we are not running the fence RT. So,
Yeah, I'm running it, but
okay, then we're then having some problem communicating. One more thing. Do you have a firewall on the host?
Yes.
Then enable port 1229. Yeah, that's a good remark. For those using the firewall, which I hope it's a lot of you,
UDP or this?
not sure, so try both. To be honest, it's a multicast thingy, so UDP should be the answer, but I have seen it also using TCP sometimes, so I will be lying to you to say I know 1229 port on the host for those running FenceVert-D should make the fencing agents happy, or at least communicating. This is the part that I'm, for example, dealing at work quite on daily basis on. It's not communicating there well and the rest of the cluster is not working properly. It is unfortunately the reason that cluster relies on the fencing to work, because it can then do the stuff. It can actually do something. Without fencing, it's something like giving your employee instructions without giving him permission to do them. So you can imagine it as that. Employee won't do it because he's scared of screwing up something, and you won't give them because you cannot communicate with him. So,
please, once more to host file and playbook.
yeah, sure. Host file you should have on the USB drive. That's example is there.
Yeah.
The playbook is something that I'm writing on the spot, but should be doable. Is there some new error that we have? Yeah, and mind the spaces. As we are using YAML, it might be really tricky on the spaces. This one looks to be fine, which I'm also surprised. But in the meantime, while you check your playbook, I will try to expand this one with the cluster resource, which will be provided from the another role, PCS modules -2. And we will actually write here some kind of task. So you may notice we are already getting to customizing the stuff, not just using the things that are available somewhere. So what we want to do, or what the paper is telling us to do, use the PCS resource module from the PCS modules -2 role to create a resource named myDummy of type dummy. And to understand actually what we need to do, let's have a look on the documentation. Yeah, documentation. So one thing you will need for documentation, as we will be looking into a module that is not in the system, it's to specify some kind of path where to look for the modules, and then specify what module we are looking for. So hopefully this will work. It is something that you have written on the paper on the front side. Just check the accessing Ansible PCS modules documentation. It's exactly what I have written. And it's exactly what you need to run in the same directory as you have your playbook. From there you get to the roles and the part, and we will see documentation on what we can do. So, unsurprisingly, I have an example here describing the dummy, but important for us is that every cluster resource must have, or is a mandatory to have, name and resource class, which I believe should be resource type. So, what we want to create is a resource with the name my dummy, and with resource type, or with a type dummy, and nothing else. So looking at this resource class, it's mandatory, but it got a default, so I don't care about it. I will need a resource type, which is defined as a dummy. State is again default, and so on. So getting back to the playbook, then I will create PCS resource named my dummy. It's hard to choose the right names, people. It's just the random that came to my mind. And with the resource type, dummy with a capital. This is a really simple resource. I will again do it somehow so you can see the playbook, and I will be running something in the meantime. So yeah, so on the top you get a playbook, and I will be running again the playbook on the cluster. It should be pretty fast this time because most of the stuff is already done. And should be green. And at some point we will get to create a dummy resource. And here's one mistake I have made that went pretty unnoticed for the cluster part. Imagine that we have now 2 nodes in a cluster that are sharing the resources. We actually want to create one dummy resource, so I have run the command here asking both nodes to create a dummy resource. They were, I would say, dumb enough to try to do that, but in the end I will have only one resource. It is possible that this happen if there's some race condition. Blame me, I write the stuff. So at least it didn't fail. What we can check if really the resource exists there, I will have a look at one of the machines. I will have a look at Sophia, the machine, and have a look at the status of the cluster. So here I can also see something is failing here, which is surprising. But no, it's not surprising. I understand why. So here I can see I got a my dummy resource that gets created, and it's actually started on the node Andre, which is great. And it is there only once. That is expected one. And I should actually write in a playbook I want to create only one resource for the cluster. So when working with a cluster part, we would like to utilize a lot of run once directive, saying like it is okay to one of the nodes just to create the resource in a cluster, as there is no difference if the resource is created from node Andre or from node Sophia. So in both cases it will be still the same dummy resource as it was before. So who got a dummy resource? Hands up. 1, 2. Here. No luck.
I've got a YAML error somewhere.
YAML error. Let me have a quick look. Okay, maybe just the spacing was problem.
No, this is because I got new. Excluding
This is modules. I think it will be.
Ah.
Right? Yep. Yeah.
Thanks.
Yeah, if you get too huge error, it's a feature, meaning like you have a typo. It won't tell you have a typo, but it's usually it. So we have a cluster with a resource. We're good, people. You already know how to do clusters with one playbook. But let's not stay on something so easy. So what I want you to show is like we would like to add some shared storage, because now our dummy resource is just nothing, a thin air running either on one or the other node, but actually doing nothing. And to actually do something that makes sense, it is a good thing to have some shared storage. So what we would like to do, we would like to use another role to set up the shared storage. There are several approaches how we can approach this. One of the easy ones is just to share a drive itself, have a partitions on it, and just have some file system there. It's a little bit clunky or not very flexible when you need to change something on that partition, as compared to some other options, which are the LVM. Who works with LVM? Good, very good. So you will also like the LVM in a cluster. Unfortunately, it's not just the normal LVM, it's called highly available LVM, and it needs some additional configuration. So, moving on the second part on our paper, to get into something exciting, we would like to create a highly available LVM of a tagging type. It's the one that is currently working with the module that you have there, as the other one I managed to broke during the week. So we will have a look at the tagging variant, which allows us to have the shared storage always only on one of the nodes, which is quite good and sufficient for our use case. We'd like to run our web server in the end only on one of the nodes. So I will start writing a playbook that I will run a little bit, and then I will walk around for more issues that you are facing. Okay, any questions in the meantime, not related to errors? Great.
How would you list all the modules which you have in your roles?
One more.
When you actually type your command, I didn't see it, and then I had to guess it.
Oh,
How do you find out what modules are listed in a role?
I will do the ls roles here.
Not find the modules, right?
What modules are there?
Yeah, because PCS modules defines the modules.
Okay. To know what modules are included there in PCS modules, you will have a look into the PCS modules library.
And that has to be like that by Ansible standards, or just?
Yeah, this is something that is a module bundled in a role. Usually the modules are bundled with Ansible itself, those ones provided in the system. And you will have to give me a moment to figure out where exactly they are in the system. It's something Python somewhere, something. And at that place you can find them. I actually know how to find it. It's a brute force, but I know there is a module named file system. It's something from Ansible. So the directory where it is hiding in the system, it is, okay, it's not.
And it's lowercase f.
Should be not.
Doesn't matter, it's okay.
Yep. Yeah, lowercase. So if you will be looking for the modules that are by default somewhere findable, on my system, meaning it might not be on your, user lib64 Python side packages Ansible modules.
Yeah, the thing is Ansible doc, if you do list, it actually tells you that. So I don't
Yep.
really need to grab them. But the thing is, if I have them in roles, I don't know, because they're not, Ansible doc doesn't include them. So I don't know, unless I specify the full path to the role, I can see. But
Yeah, the problem is when it's included in a role that it's in the directory, it's not picking it automatically.
yeah,
So
yeah.
that's a nice one. Okay. So thank you for the question. Good for thinking how to place them more intelligently. So still, in the meantime, I will move a bit forward. I will try to make another playbook. And I like reusing the code. So um, we'll make it a bit differently here. I will still use some of the roles I have, but I'm not willing to copy the top part. And again, we need to look up some defaults from the role that we are planning to use. We'll be using the role HA cluster LVM, which is trying to automate for us setting up the HA LVM setup with all kind of quirks and requirements that doesn't really bother us as long as we just want a highly available LVM. We just want it to work. So what do we actually need? We will need a shared drive, as most probably the one as a default is not the one that we want to use. On a virtual machine, if you use the file I gave you, it should be the dev.sdb or the second drive or something that is not the normal system drive. Then we specify we want to use the HA LVM type tagging. That is a default, which is good enough. And we want to name our cluster VG somehow. So how to name it? Is here some mic? Good. So I will use mic.
Can I have a question if the shared drive is named differently on both nodes, because yeah.
That will be a little bit tricky. That will be a lot of tricky. So for the different names, there should be some identifier in dev disk by that will still lead to the same drive, but to be honest, it might just not be there for empty drive. So you can you can actually make a symlink on your machines, which is a dirty approach, but will serve the purpose. Yep. I think the dirty approach will be create a symlink with the same name on the both machines, pointing to the right device, and then refer to shared drive to that symlink. The system will follow up the symlink and set it up there. And I'm curious how well this will work, so go ahead with that one.
Maybe it will be quicker to like start a new, create a new virtual machine with the standard array.
It depends. If you are missing the drive somewhere, just add another one, or you can add actually drive to both of the machines and then have the third drive named same way. So that will be again a dirty workaround. Okay. One thing I will try to progress here before you figure out how to trick your nodes into having a shared drive with same name is
the UID.
UID should be usable, but it's usually fixed to file system or partition. And if we have the empty drive, it might just not be there. So example that we have in the defaults is pointing to device on iSCSI, which is easily identifiable because there's IP address and usually you're using the same, but again might be different. So that's quite interesting. I will therefore still move a bit forward. The one additional thing that is mentioned in the notes. Yeah, but the bypath can again just point to the other things because the local drive will be again the path 1 or 0 somewhere elsewhere. So one additional thing, if you use the LVM on your virtual machine and the one that I have provided you is using it, you need to specify one more nifty thingy, and that is a list of the local volumes. This is something a bit manual. It's related to way how the HA LVM tagging works. It needs to know by hand what is considered local. At some point it's hard to distinguish the other way than just by telling it. Compared to the another approach that can be used with HALVM, which is called CLVMD, that one has some flag through which it can detect, okay, this drive is a shared one or the clustered one, the other one is not. But for the tagging one, we don't have such information in the system that will just tell us, yeah, this one. So we need to tell system, this is the list of VGs that are local to that machine. And surprisingly, as before, that should be it. So looking at the role, which looks pretty shy and short, I will go ahead and run it. And I got an error. Wow. So yeah, this is the same error as no. Okay, this is the one error I put here intentionally. So one more thing that you will have to do: go into your roles and create a symlink for the PCS modules without the -2, which is the old module still used by the HA cluster LVM, which should be rewritten soon, but it's still not there yet. But for our purpose, it should be enough to just symlink it there. And after that one, you should be able to run the playbook. The playbook is up here, so you can see it. It will do a bunch of stuff. It will rebuild your initramfs. Who knows what is initramfs? Good. You like it being rebuilt, don't you?
Depends on what's going into it. But, yeah.
A lot of great stuff.
Yeah.
So,
probably needed during boot time, so yeah, it makes sense.
yep.
So what is it in initramfs? Is this the partition thingy which we roughly throw in to just boot up the kernel? Or?
Yep, that's that part of the thingy that starts before even mounting the root file system. And it hits the part why we are actually rebuilding it. The reason is we have changed the LVM configuration that continues something we would like not to be detected or activated during the boot. So that is why we are including configuration not only in etc LVM LVM-conf, where it is available when the system is running, but also into initramfs, where it looks before the system starts running. And that is the point at which we want to prevent our system from doing some wrong stuff. For example, at that time, the system might just think that our shared LVM is a local one and just try to activate it. And then you can imagine what can happen if 2 or 3 machines do the same, and then you suddenly see, or you don't see the LVs there, or some checksum errors. That's pretty much it. It will access the shared data that it should not. The HALVM tagging variant, in its idea how it works, is doing one really simple thing, and that is using the tags, as the name suggests. It uses the tags that it says, this VG has a tag node 1. And each node has a definition saying like, you can access all LVM stuff that is in the local volume list that we specified manually, and all the stuff that bears our name. Meaning node 1 can access the VGs that have a tag node 1. Node 2 can access the VGs with a tag node 2. This way it is guaranteed that they won't try to access the LVM that it's not local or not tagged by their name. And this is the way how they are just handing it over. They remove the tag, put the new one, and then another node can take it over. That's also the reason why it can be accessed only from one of the nodes at a time. So, time for checkup. Who is stuck on something? Broken horribly beyond repair? Great. I'm a little bit disappointed that no one broke the system completely yet. Yes?
Can I use LVM tagging for two nodes cluster for live migration of virtual machines? Or not? Because there is some point where I need the storage available on both nodes.
For that one, I would have to look up because the live migration is something a bit special there, and I think it's working with the tagging variant there, and it's doing a little bit of magic. You cannot use it if your virtual machine disk resides on the file system on that LVM, because apparently it would mean you need to mount ext4 or whatever local file system on two machines at the same time. This will make corruption to happen there. So in the case you got it on file system, no. But if your machine is using just the LV, in that case I think there is some procedure that it avoids this tagging issue, but I will have to really check in the code that part. But for the file system, for sure not. This one I'm aware that with the live migrations there is something. It's not always needed to have the CLVMD for live migration, so I believe this is the part. We can have a look afterwards. Thank you. Good one.
Am I supposed to see the vulnerability on both nodes?
Yes, it is good. You see it on both nodes, but it doesn't contain anything. So let's create some stuff.
But I don't see it on the second one.
Oh, that's not good. And have you shared the drive?
Yes.
It's not very good. It's unfortunate.
Maybe the reboot will do it.
The reboot should be not needed. We are in an environment that should just work. And let me have check if I can even see it. I'm just assuming that my machines are doing fine when I'm running the playbooks and not checking them.
I see the only on one.
Also only in one. Okay, I don't see it here. I can see my gear. I got a maybe idea what will be happening there. So let's try the nope. Okay. That's interesting.
Isn't the STP read-only or
No,
not readable by?
should be not, but that's the interesting part why we don't see it there. Okay. Don't look now, you will see a horrible thing happening. Yeah. Size? No. Okay, just I will go. Ah, thank you. Looks like zeros here. And looks like something here, meaning we don't see it, or it's not the same drive. Which would mean we have set up machine improperly, and that will kind of ruin the rest of the stuff. So let's try to fix it. Okay. drive is here, and I believe the second one should be the same. Okay. Looks to be same. So the hypervisor is playing tricks on us. That's not nice. Okay, let's try to reboot. That's quite a... It doesn't help? Okay, I'm really sorry maybe for the hiccup, because thinking about what I tried, it was also the file. I'm using mostly the block devices. So, yeah.
So also I see that two processes and the file.
Let's see, we don't have anything. No, it's not complaining about any stuff here. So, okay, one more idea that came to my mind is if the one that can see it has actually written it down there. So something like we would see that even after reboots. Oh. Okay, everyone. Looks like we got a problem here. But I will try one thing. I will try to turn both of them down and start them in a different order, which I'm guessing what will happen will be a horrible thingy, but okay. So I wanted the 249 to start first. So node 2. Okay. Let's start node 2, then node 1. So, still what is in front of us, if we manage to get the shared drive to look like a shared one, is creating some LV on it. In this HALVM tagging, it's a bit special. And creating some file system on it. And looking at the time, I think I will be mostly sorry for not getting into the last part, but we will get as close as possible to that one.
Reboot of the both machines or power off and shut down the start the game.
Not really.
Yeah, I can see something happened here when I powered them off and I started first the one that was started the second, but I'm guessing it's just playing a tricks on me. So despite of that, I will try to continue and maybe we will see how it looks when you believe your storage is shared but it's not and something horrible happens. So I will try to at least demonstrate how we can move forward on, assuming once we get the shared storage it works, and see what can be done further on. can you try really powering them both off and first starting the second one?
It's not fine. I powered them both and started the first one and then the second. No, then it's okay.
Okay. So let's get further on. We will try to create the LV and the file system. So oh no, I will do it as you know me. I will do it the quick way. So here I believe we don't need any special roles. We'll just do some tasks. And those ones will be the pretty lame ones. If you want to figure out why I'm using the task that I'm using there, it's the second horribly long link on the front page in documentation. That one is explaining how to add the LV into HALVM properly, as it's not as straightforward as you might think of. Because the role that we have has limited the access to the VG that is shared in a way that it should not be accessed by multiple nodes at a time. So it is actually preventing us to do a lot of stuff to harm our data, and we need to circumvent them in a good manner to really create something there. So it consists mainly of adding the tag. As I was mentioning, we need to have a tag on the VG to be able to access it. Here is one different thing as one I was talking about, as the stuff changes over the time. We'll be adding tag pacemaker, and we'll be then trying to access our data using that tag with some quirks in configuration. It sounds maybe weird. It's the official procedure how to do it right. Important part, you should do it only on one node at a time. Doing on a boat, of course, result all nice stuff happening. Let's start with data corruption, loss of data, and so on. So, going a bit through this part, I will add a tag to my VG mic, and I'm sorry this is not automated as much as it might look like from here. I will try to activate my VG mic, and I will use a special trick to get it activated. Otherwise the normal configuration will not be able to do that. So the volume list will give me some specialty inside. So be prepared. I will be now more writing than reading and doing a lot of stupid mistakes in pronunciation. The whole purpose of the stuff is to allow one of the nodes to really access the VG on which we want to do some stuff. And I'm missing here somewhere. No, I'm having here too much of quotes. So this way I will actually activate the VG for us to make any changes. After this thingy, I would like to create a logical volume, which is the standard module shipped by the Ansible. And this one contains on another stuff on how to create it. And to show you off a little bit of how it looks like, I will maybe skip now on showing that off to not slow down the presentation after me. I will show you actually how this looks like further on. Sorry for we got lost a little bit in a time, but let's have a look at the solutions. So, playbook solutions. You wouldn't believe how the first one looked like. The same as ones I have written now, but on what I wanted to write here, is like actually creating LV, and this will be more of a session on how to look like on the stuff. You can still follow up the paper and try it out at home. I will hand over also the thing that you should have in the result as a playbook to try it out the right way. But for just getting through that so we know what will be happening, let's have a look how it is there. So here I'm using the cluster VG as the VG name, and I'm creating LV named data. Size 512 max. The special thing that we need to pass is again the config activation part that we used for activating the VG. This one will allow us to create the LV and make it active. Make it active means the LVM can have LVs, but some of them might be just not available to us, meaning they are not active. The ones that are active can be accessed. There is a dev cluster VG/data file, or this is a symlink to the DM device that we can actually use. If the LV is not active, the symlink is not there, we actually cannot even access the data, even if we know the LV exists. So to actually create a file system, we need this LV to exist and be accessible. That's why we use the activation command. Then we create the file system. Here it's an XFS on that path. And once we got that one, we get to the procedure that we done in the beginning, but in reverse way. We delete the tag and we deactivate the VG. You may notice I'm not using any special configs there. LVM is much happier in deactivating the stuff than activating it. So if you want to prevent something accessing, it's much easier than making it work. So that's why I can omit a lot of stuff. This will create for us the LV with XFS file system that we can use further on. And the part that we will be looking further on will be how to get it into the cluster, because the cluster itself, we'll see now, HALVM, it's somewhere but nothing is managing it, it's just sitting there. What to do with it now? For the way so it can be used for something useful, we need to create a cluster resource for the HALVM, tell it which volume group it is, and use a special keyword exclusive true, meaning like we want to exclusively to run it only on one of the nodes. I believe this is something that it's not used when the live migration is in place. So that will be maybe also the reason for it exists. But still we can have a look on what is there. Then once we have the LVM in a cluster, the cluster will take care of activating on one of the nodes, meaning this tedious job of VG change, activation, and so on will be done by cluster, and one of the nodes will have active LV that we can access. On that LV there is a file system which we can mount, which is another cluster resource, obviously named file system, and we again just specify to it which device it is, in which directory to put it in, which file system is there. One of the tricky things that I would like to at least introduce to you is that the cluster, despite we are telling, okay, we have a dummy, we have a LVM resource, we have the file system resource, there is one problem. The cluster will start it in a way how it is specified there, but what if we want some specific order in which it should start? We then use in a cluster something named constraints. There is a module PCS constraints that allows three important things. Choose the order, meaning first activate LVM and then mount the file system, as it doesn't make sense otherwise around. Second interesting constraint is co-location. The node on which you activate LVM, on the same node try to mount the file system. Again, it doesn't make sense if on node 1 I got LVM running and on node 2 I try to mount the file system, which will obviously fail. But it will just generate the messages. And the third constraint that we can use is a location one, which says like, I would prefer if the whole thing runs on the node 1 if possible. Otherwise the cluster will just choose one of them. all of them are quite equal. They have some scores on which they decide, but without any special guidance, they just decide on one of them. So these are the constraints that we can use, and it's important to use afterwards. As you can imagine, the last part of the presentation, which is installing the Apache and running some resources from it, it's just addition to what you can see here. It's enabling some file system, mounting it somewhere, and making some stuff there. So I will not show it here and leave it as a homework for those interested in, or if anyone interested, I will be outside for talking a bit more of it. But because I'm a bit out of time, I will be kind of ending it at the time of saying we got at least to the cluster with shared storage, kind of. We have some resource, but we know how to do it further, and it's more like exercise. So I hope it was not too tedious or boring here. I hope you can finish it further on. The materials will be available somewhere. See, I didn't have even used this slide. And I would like to really thank you for getting here, trying out some stuff, saying me some nice things of what is broken and so on. As a lot of work here was done by me to ease my daily workload, and I believe it's worth sharing with the others, and that was the whole point of sharing this with you. So thank you for your attention. Enjoy the rest of the DevConf, and feel free to go with me for a coffee if you got more questions. Thank you. The playbooks, if you check the actual address there with the only/blog, you will see some examples with the whole playbooks, but actually the cluster is just that one line that we already created. The first playbook is create a cluster. I have also solutions for RG Manager, which is the older version, and I have the alternative with a shared drive on iSCSI with the needed roles to configure the server and the client. Yeah. Feel free to keep the papers. You can use them. Please return the flash drives.
Thanks very much.
Thank you.
May I ask?
Yep.
Probably English still.
Yep.
I have seen that you have the PCS libraries that manipulate the PCS resources, constraints, and so on. And I work on these two last 3 months. I'm building the Postgres cluster into failover using PCS and using Ansible. And I was writing these libraries on my own, and I see you're quite sophisticated because you also check the difference and push the CID and so on.
That's the part I'm not very proud of,
But I assume you wrote it.
Yeah, the difference is it's a nice one how to do it, but I have seen one nasty bug, which happens when the cluster configuration is large. It might take just too much time, and it might fail during the process. However, I haven't reached yet that size of the cluster we're testing it.
I see.
Thank you.
Anyway,
Andre, I just want to thank you very for because I have to run to the conference. Thank you very much. I think your teacher just did there. Yeah.
and I just seen that you have also I switched to Videl som, že máš na GitHube, takže to máš pod GPL trojkou licenciou. A jak my to robíme pod Apache. Že trochu problém, že to spýta, že či to môže použiť, ale vlastne
but if we run out,
nemôžem použiť.
don't have people like
Či by si
stay,
bolo
we can do anything.
či by bolo možné si to použiť pod inou licenciou, keďže si tvorca.
Jasné. Co by quiz? Když se pozerám, takhle jsem se fungoval. Úplně povedané, já jsem tam dělal trochu z toho důvodu, že jsem nemal silnější preferenci v dané době a chcel jsem hlavně udržet to, že v případě, že by někdo
Andrei, let's leave the
You're
room.
Andre? Yes. Let's shake hands. My name is Theo. We had a little bit
Please
of contact
set
with
your
one of the
computer.
last
Yeah.
cases for
Andrei will.
Or if you want, you can write it down for me and I will say it. But better if you just
Yeah,
yourself.
you will.
Thanks.
It's great to see the face behind the case.
Thank you very much.
Yep.
Definitely.
Thank you.
Bye.
Bye-bye.
Yeah, I've seen that one, but to be honest, I got quite late into that case.
We need to
So there was some
the
stuff
next
already done.
one will be sooner after us. So whatever is, you can continue.
I will just go out so they can continue here.
The internet is a little slow.
Yeah, I know.
Or non-functional, I would say.
Yeah, I hope that you are ready for
Yeah, yeah.
problem with this.
Chceš do mě snad kafe nebo...
Já teď mám vodu.
Jo?
No.
Water? Yeah, water we have, but I'm asking about coffee.
Andrei,
The flatbread. Klidně ti donesu kafe.
yeah, I
Řekni si.
Okay.
Ne, dobrý, okay.
Honzo, jak dlouho to plánuješ? Iba tak orientačně.
Já nevím. Ale jako, já tam chci ukázat pár jako věcí, ale pak si ještě věnovat jako...
Next room is
Ne,
on
ne, v pohodě, jako mě len tak jako, že za hodku a půl,
Jo,
ještě možno, že půjdeme na jinou prezentačku, hej, len aby si to...
Jo, jako to hlavně určitě stihnu.
To si ne, že jo? Jo, dobrý.
Maybe double check with Chris.
I looked at it, we don't have anything for that there, so I thought, let's try to create something. And this is like an ongoing job that kind of is amazing when you're organizing this, they get out, especially the other people, and I'm telling the job that they need skill that can replace your skill that deploying stuff. It sometimes takes more than a week to achieve something we can do